All right, special products. These are the same thing we've been doing, but these are ones that have a little bit of a shortcut to them that can speed us up in multiplying out certain types of polynomials. We'll start with these first ones. And when can you recognize these special products? So look at these two factors or two sets of parentheses. What do we notice about them? Yeah, they're the same, but one has plus, one has minus. That's exactly right. Okay. But the pieces are the same. You got x, and you got 4 and 4. One's a plus and one's a minus. Now, in yesterday's work, we did x times x is x squared. X times negative 4 is negative 4x. And then we did positive 4x and negative 16. What happens to those middle pieces right there? They combine, but negative 4x and positive 4x together does what? 0x, so it cancels each other out. So the final answer is x squared minus 16. The shortcut is if they match like this, except for one's plus and one is minus, you can just square the first thing, get x squared, square the back, 16, and put a minus sign between them. That's the shortcut that can happen. That's why it's called a special product. So like example B, if we had something like x plus 6 and x minus 6, we can take that shortcut because they match except for one's plus and one's minus, square the front piece. X times x is x squared. And then square the back piece. 6 times 6 is 36. Put a minus sign between them. Because it's this that fits that pattern. They're the same except for one's a plus and one's a minus. So that's the shortcut that we can take. Example C. Take something, just almost just like that. Say x minus 7 and x plus 7. They're different order. The minus is in the front and the plus is in the back, but it's the same, right? X and 7. X and 7. One's a plus and one's a minus. So we can still take that shortcut, square the front, and minus the square of the back. So it's just x squared minus 49. That's that shortcut. Now you can still do it the long way, the way we did example A, where you just distribute twice. You can still do it that way. It's absolutely fine. But as you do more of them, you're going to think, okay, I can do this a little quicker by doing this. Okay, so it's a little bit of a shortcut out of that. Let's do another one. Let's say we had something like 2x plus 3 and 2x minus 3. So we got a number on the front there, but they're the same, right? Except for plus and minus. Okay, so when we square 2x, what's 2x times 2x? 4x squared. And then what's 3 times 3? 9. And then it's a minus in the middle. That even with a number in there, you can take that shortcut. Say we had like 3x minus 8 and 3x plus 8. Are they the same except for plus and minus? Yes. So that means we got a shortcut. Square 3x. What's 3x times 3x? 9x squared. What's 8 squared? 64. Minus sign in the middle. That only works, though, if they are the same except for plus and minus. If it's anything else, you've got to do the distributive property. And again, you can still do distributive property like we've been doing. That still works absolutely fine. And combine like terms. That still works. But this is just a shortcut to kind of help speed up things when you're multiplying it out. So it's a little bit of a shortcut. So that's one of the shortcuts for special products. The factors match, except for one's a plus and one's a minus. When I say factor, I'm talking about the parentheses parts. Okay, so that's one of the shortcuts. And then the other one is when we're squaring the same, a binomial. So let's say we're taking something like x plus 5 and we're squaring it. What does it mean to square something? Times it by itself. X plus 5 times x plus 5. That's what it means to square something. Then we can work that out. Is this the shortcut that we've been doing? No, they're not exactly. They are exactly the same. They're not. One's a plus, one's a minus. So this is not the same shortcut. You've got to do this one a little bit differently. If we do distributive property like we did last couple of days, we just say x times x is x squared. X times 5 is 5x. And then distribute the 5. It'd be another 5x. And that'd be a 25. Notice in the middle, they don't cancel out. Plus positive 5 and positive 5. If you give me $5 and then you give me another $5, how much I got? I got $10, right? So that's double in the middle, right? So we get x squared plus 10x plus 25. And that's your answer because we've combined all the like terms that there are. The shortcut to that is square the front, square the back, multiply them together, and double it for the middle. Square the front, that's x squared. Square the back, that's the 25. What's 5 times x? 5x, double it. That's 10x. So that's the shortcut when we're doing that. And let's see if we can start kind of applying that. If we had x plus 7 squared. So the shortcut is square the front. What's x when we square the front? X squared. Square the back. 7 squared is 49. It's always going to be a plus right there. Multiply the two pieces together. 7 times x. Double it. 14. That's it. So that's a little bit. You can still write it out like we did here and do the distributive property. You can still do it that way. Kelly, please close your computer and pay attention to what we're doing. You're paying attention to close the computer just a minute. Okay. All right. So let's look at another one. Let's put a minus sign in there. Let's say we had x minus. Let's do x minus 7. It's a similar problem, but it's got a minus sign in it, so it's slightly different. Again, the shortcut for squaring a binomial is square it, square the front, square the back. 49. Now, technically, this is what kind of 7? Negative 7. If you take negative 7 times negative 7, what kind of 49 do you get? Negative times negative is a positive. So that's why I put a plus sign in front of that. Remember, I said it's always going to be a plus on the end down here. Now, the middle part, we got a, what kind of 7 is this? Negative 7 times x is negative 7x. Double it. Negative 14x. So that's where the minus sign goes in the middle. Whatever sign's in the middle here is going to be in the middle here. Here's a plus sign in the middle. That's a plus sign in the middle. It's always a plus on the very end when you're squaring a binomial. Always a plus. Do want another one here. Let's say we had 3x minus 5 squared, which is 9x squared. 5 squared is 5 squared. 25. Thank you. And then what do we do to get that middle piece? Multiply them together and double it. So 3 times negative 5, negative 15, double it. Negative 30x. Good job. We have 4x minus or plus 11. Go ahead, Tyler. Go ahead. You're saying it. What's the first piece? Mm-hmm. You talking about the third term? All right, the last piece is what? Say that again. How much? 11 times 11. 121. And then the middle piece, multiply them together. 4 times 11 is 44. Double it is 88. 88. Notice it's a plus sign right here because it's a plus sign there. It's always going to be the case. Okay. These are shortcuts, but they've got to be a certain way before you can do that. Okay, so you just throw one out there. What's that shortcut? Just throwing it back in there. Okay. X squared. Nope. Take the shortcut. They're the same. One's a plus, one's a minus. Minus 81. So that's the first shortcut we went over. Is that one a shortcut? No. It's almost one. It's got the plus and the minus, but they don't match exactly. So how do we do it? Just do it the way we've been doing it for the last 2 days, right? So x squared negative 15. Combine your like terms. Negative 5 and positive 3 would be negative 2x. So that one's not a shortcut. You've got to be able to recognize when is there a shortcut, when is there not. If you want to use the shortcuts. In Algebra 2, you're going to need to know them because you've got to be faster than having to write it out over and over. So I want you to learn the shortcuts and try to get faster at them. Let's do another one. Let's say we had x plus 3 squared. Nope. Mm-mm. Is that a shortcut? Yes. Square the front, square the back. What's in the middle? Nope. 6x. 3 times x and double it. That's the shortcut for those. Okay? It takes practice on these shortcuts, and you've got to practice using the shortcut to be able to get good at doing it quickly. Okay? The distributive property for problems like L, that just takes the time to do it and combine like terms. With the shortcuts, it takes practice working on the shortcut to get better at it. It's kind of like running plays in basketball. When you start trying to run like flex offense or something like that, that is not easy to do the first day. It takes a lot of going over to do that. Shortcuts in math take a lot of going over to make them, ingrained in what you know how to do. So you've got to practice these to get better at it. So we got some practice to do today.